Hello everyone. So I'm Falguni, your chemistry SME. Let's start with today's question and answers. So the first question is, which of the following elements of 5D series is the highest melting point? Okay. So see, we all know that in any row or element, the melting points of these metals peak near the middle. Okay, because why? Because number of unpaired electron increases. Okay, so that is why the interatomic interaction will be more. Now in these, if you will see this, okay, so it has maximum number of unpaired electron because it has this configuration. Okay, it is 5D series element. So it has six number of unpaired electron. So that is why this would be the answer. Let's see the next question. Choose the correct order. We have to tell the correct order. So see, here it is given that uh, Na positive is greater than Mg plus 2, which is greater than Al plus 3 for hydration energy. See, in case of hydration energy, this is not true. Size is the least for aluminium. So it has maximum hydration energy. And then in the next case, if you'll see ionic mobility, yes, this is true. Why? Because see, in case of lithium, sodium, and potassium, size of lithium is greater than is smaller than Na, and which is smaller than K plus. So in aqueous solution, the smallest ion is the most hydrated ion. Okay. So if it is most hydrated, that is, it has water molecules around it, more water molecules. Okay, so it has difficulty in moving. So ionic mobility would be less. So it would be maximum in case of K plus. So this is our correct answer. Okay. So in the next question we have the size of the following species is affected by. See, we know these are isotopes of hydrogen. Okay, and isotopes of hydrogen are not affected by nuclear charge and atomic mass, neither by valence shell principal quantum number n or electron-electron interaction. Why? Because of their same size. Okay, and that is why they have identical chemical properties. Let's see the next question. It says the name of the element having atomic number 104. So see, for this you have to learn few things. See, rutherfordium, this is official name. Okay, it was adopted by IUPAC. What is IUPAC? International Union of Pure and Applied Chemistry. Now, anil quandium. Okay, so this was also a temporary name. On 1 nil 0 quandium 4. So this was also a temporary name. And this was also another temporary name for element 104. So all of the above would be the answer. Let's see the next question. Which of the following species atomic orbitals are filled according to Aufbau principle? See, we know that in Aufbau's principle, energy electrons will be filled in increasing order of energy. So lower energy orbitals will be filled first. So see, in case of Cu plus, Zn plus 2 and Kr, what will be the electronic configuration? This would be their electronic configuration. Therefore, all of these are filled in the order of, in accordance with Aufbau's principle. Okay, so this would be our correct answer. Let's see the next question. Gadolinium has a low value of third ionization enthalpy because. See, let's see the electronic configuration of this element first, which is this. Now it is asked that it has low ionization enthalpy. Now you can see that the value of third lowest. third ionization enthalpy. So what will happen is after two ionization enthalpies, you'll see in case of third ionization enthalpy, electron will be removed from 5D. In first two, it will be removed from this, and in third, it will be removed from 5D, which has 1. Okay, and the resultant would be the XC 4F7, which is half filled and extra stable configuration. Okay, so it will have high exchange energy. Okay, so less energy would be required because it is just one shot. See, D0, D5, D3, and D6. These would be the case in which electron would be removed very easily if these configurations are achieved. Okay, so that is why if it is D1, it will also readily lose electron to form D0. If it is D4, then also it will lose. So that is why the answer would be 2, high exchange enthalpy. Let's see the next question. Which of the following statements is correct about modern periodic table? Which of the following statement about modern periodic table is our incorrect? Okay, I'm sorry, we have to tell incorrect statement, not the correct one. Let's see. The elements in the modern periodic table are arranged on the basis of their decreasing atomic number. No, they are arranged on the basis of the increasing atomic number. Increasing atomic mass, again no. Isotopes are placed in adjoining groups. No, they have the same atomic number. So this is correct. So first, second, and third would be the answer. These are the incorrect statements. Okay. Let's see the next question. Which of the following is a metalloid? See what happens in a metalloid. These have properties that are intermediate between metals and non-metals. So, which all are the metalloids? See, silicon, germanium, arsenic, and antimony. Okay, these are the metalloids. Let's see some of their properties. They exhibit mixture of metallic and non-metallic properties. Okay, so for example, they may conduct electricity like metals, but are brittle. Okay, and less malleable like non-metal. So they acquire properties of both. So our answer would be this. In the next question, among O positive, O2 positive, and O2 negative, the species having the most positive and the most negative LHE respectively. Okay, let's see. See, the successive electron affinity always decreases. Okay. Now, when O is formed, when O accepts an electron in O negative forms, it would be negative. For O2 negative, it would be positive, and then again it would be positive. Now, what happens is, in this case, you can see that in the succession, it is forming positive electron affinity. That is why it will show most positive. O2 negative will be most positive, and O2 plus, which will come first, like it will come before O. Okay, so it will be the most negative. If this is negative, that will be even more negative. So our correct answer would be O2 negative and O. Just a second. Yes. So here it is. O. Wait. Let me just correct. Yeah. So this is the right answer. This is correct. Let's see the next question. Yeah, so this assertion says group 17 elements have high negative electron gain enthalpy, and the reason is they can attain stable noble gas configuration by putting an electron. So, see, both of these are true. The reason would be the correct explanation. Let's see why. See, in case of halogen, the configuration they have is outer shell has 7 electrons. They are one short of stable configuration. Okay, one short of 8 electrons. So therefore, easily they will acquire an electron upon addition. So they have high negative electron gain enthalpy. Okay. So also halogens, they release a significant amount of energy when they gain electron, and the other one I already told you, they are one short of achieving 8 electron configuration, which is a noble gas configuration. Now let's see the next question. Which of the following statements is incorrect? Formal charge and bond order of NO is this. If this is correct. This is wrong. The other are correct. So this would be our answer. Why? Let's see. What is the in XCF4? We have two lone pairs. Okay, and in order to get four unpaired electrons, that is two lone pairs. Then two electrons will get excited. Okay, for second excited state. Okay. See, if I have these many electrons in second excited state, then earlier it would have had more electrons. Okay, so XCF4 will not be formed in first excited state. It needs more electrons. In first excited state, it will not lose four electrons. Okay, we want four unpaired electrons. That is why. Let's see the next question. The number of hypervalent species among the following. So, what are the hypervalent species which have more than 8 number of electrons? So, let's see for ClO4, it has, let's see structure. Okay, so how many electrons it have? 1, 2, 3, 4, 5, 6, 7. It also has electrons because these are covalent bond, that is sharing of electrons is there. It also has electron of the other part, that is this one. So it has more electrons than 8. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So it has 14 electrons. So yes, it is hypervalent. Similarly for SO4 2 negative, let's see its structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It also has 12 electrons. Okay. So this is also hypervalent. For CO3 2 negative. Okay, so for CO3 2 negative, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it has 8 electrons. That is, it is not hypervalent. For BF3, we all know it is electron deficient species. It has only 6 electrons. BeF4. See, for BeF4, what happens is F negative here will donate its electron. It has 2p empty orbital. So it also has 8 electrons. So this is also not hypervalent. Let's see for SnCl4. It is again because 4 chlorine are there. Single bond will be there. So it has 8 electrons. CF4. Yes, XCF4 is hypervalent. You see structure of it already had 8 unpaired electrons. Now it has formed bonds with 4 fluorine atoms. That is, it has 4 electrons more. That is 12 electrons. So how many species we have now? 3. Let's see the next question. Which of the following order for ionic radius is correct? We know that any ion which is, say, let us say cation. So Fe3 positive is lesser than Fe2 positive. In 3 positive, it has even lesser electron than Fe2 positive. That is, electron decreases in size also decreases. Okay. For O2 2 negative and O2 negative, this is the correct answer because here electrons are more and size would be more. In case of anions, this will happen. Okay. Negative charge is directly proportional to ionic radii. So this is wrong, and this is also wrong. Let's see the next question. From the following pair of ions, which one is isoelectronic, that is having same number of electrons? So this is tabulated here, and you can see Na plus and Na2 plus is isoelectronic. We have been asked which is not an isoelectronic. It is isoelectronic. Mn2 plus and Fe3 plus, this and this. These are also isoelectronic. Fe2 plus and Mn2 plus. These are not isoelectronic. So this would be the correct answer. Let's see the next question. The element having greatest difference between its first and second ionization energy. See, here this could be, answer would be this. Why? Because this is an alkali metal. Okay, so in this, for example, if the configuration is NS1 for the first ionization enthalpy, it will form NS0. Okay, so that is why it has like achieved a noble gas configuration. So this will have the most specific difference. Now let's see the next question. 66. If the first ionization enthalpies of elements X and Y are these and this, respectively, and for second ionization enthalpy X and Y, it is this. See, we already saw that for alkali metals, the first and second ionization enthalpies have a more difference. So, see, this has like they have much difference. So, it is alkali metal. Okay, just a second. So, X is alkali metal. It's not broken. Yeah. So X is an alkali metal and Y is an alkaline earth metal. You see, the difference is not so much as compared to this. So Y will be an alkaline earth metal. Let's move to the next question. 67. Okay, first let's see one more explanation. In element X, the nuclear charge is not much. Uh, and in second ionization enthalpy, it is significantly high due to large nuclear charge. Okay. So in the next question, the correct sequence given below containing neutral, acidic, basic, and amphoteric oxide respectively is. We know that for amphoteric oxide we have ZnO and Al2O3. Okay. In this, if you see, ZnO is present only here in the last one. We have to tell, see, amphoteric oxide is on number 4, so ZnO should also be number 4 here. So this would be the correct answer, but let's see the others. See, basic oxides, they react with water to produce base. Acidic oxide will produce acid, and neutral oxide will not display any significant acidic or basic properties. So that is why this would be our answer. Let's see next question. Given below are two statements. Boiling point for hydrides of group 16 elements is H2O has maximum, and then this. And second statement says based on the molecular mass, H2O is expected to have lower boiling point, but due to presence of extensive hydrogen bonding, see here both the statements are true. What happens is, see H2O, it has hydrogen bonding, therefore it has the maximum boiling point, and then it would come here. See, the trend should have been, why? Because of the molecular mass. More will be the mass, then more will be the boiling point. This should has have been the trend, but because of what? Hydrogen bonding, it will be this. So these are both correct statements. Let's see the next question. So this is easy. We have to match the column. What is Mendelevium? It's MD. Mendelevium. Then Metalloid would be MT. Then Moscovium would be MC and Nobelium would be NO. Okay. So this would be the correct answer. In the next question, we have been asked which of the following are the isoelectronic species that is having same number of electrons. So our correct answer would be this. Let's see. Why? Because this is the number of electrons 8 plus 2, 9 plus 1, and 11 minus 1, and 12 minus 2 from the atomic number. We will be subtracting or adding the electrons. So that is why this is isoelectronic. Let's see the next question. The first member of p block elements displays greater ability to form. Yes, okay. See. So the first element of first member of any block, especially p block, they always shows greater ability to form multiple bonds with itself. We have seen carbon, carbon, oxygen, oxygen, carbon, triple bond, carbon, nitrogen. These have more ability to form multiple p-pi bonds rather than p-pi d-pi bonds. Okay. So let's see the next question. In the next question, which of the following is an incorrect explanation regarding atomic radius? Atomic radius changes with when atom is present in different bonding states. This is right. Atomic radii are measured by either X-ray or some spectroscopic methods. Yes, this is also right. Atomic radii classified into covalent and non-metallic. This is wrong. That is why this would be our answer. Why? Because it is classified by covalent and metallic radii. Okay. So we have our answer here. Let's move to the next question. Consider the following statements. S block elements are found pure in nature. D block elements form colored ions and exhibit variable valence in ferromagnetism. Yes. Lanthanoids contain elements from this to this. Yes, from 58 to Z71. Actinoids contain elements from thorium to Z equals to 103. This is also correct. Okay. So our correct statements are this because CY. S block elements are never found in pure nature because of their high reactivity. Let's see the next question. Consider the following statements. Electronegativity generally increases across the period from left to right. The see this is we have to tell the incorrect statements. Okay, incorrect statements we have to tell. So here this is the correct statement. Size decreases, electronegativity will increase. The attraction between the outer electrons and the nucleus increases as the atomic radius decreases. Yes, if there will be lesser number of electrons, lesser would in case of lesser radius, then obviously nucleus will have more effect. Nucleus will shield it better. In the next statement, the increase in electronegativity across a period is accompanied by an increase in non-metallic properties. Okay. Then the next is the valence of representative element is always equal to the number of electrons in the outermost orbital. See, this is wrong. Okay, so our answer would be only 4. Let's see why. Our representative elements take part in a chemical reaction to complete its oxide. See, every element, everything in the nature needs stability. So in this process, the element will either lose or gain its electrons. Okay. So it is usually equal to the number of electrons in the outermost orbital and or equal to the 8 minus the number of outermost electrons. Okay, so it needs to gain stability. So it will either lose or as well as gain electrons, which will be different, which counting will be different from the valence electrons. Let's see the next question. Match column 1 with column 2 and select. See, this is easy. Helium. See, it is 1s2, therefore it is in stable state. So it has high ionization energy. Okay. Fluorine. Fluorine, we all know it is the most electronegative element. Then we have rubidium. It is the most electropositive element. Okay, it comes in the alkali metal series. Lower it comes. Okay, it comes after, even after potassium. Okay, and then we have lithium. It is the strongest reducing agent because it is smaller in size and has a positive oxidation state. So it will act as a stronger reducing agent. It will oxidize itself first. So correct answer is this. Let's see the next question. Assertion says noble gases are highly reactive. This is wrong. Noble gases are inert in nature. Noble gases have stable outer configuration. This is true. For assertion is false and reason is true. They have they do not have any unpaired electrons. So that is why they have stable outer electronic configuration. Let's see the next question. Which of the following is the correct order of the given species size? C. This is the correct answer. Why? Because any anion will have more size than element than cation. Okay. So this is the order. Now let's see the next question. Alkali metals are powerful reducing agents. Why? They are metals. This is not any reason. Their Ionic, see, it has always to do with the reducing and oxidizing agents. They always have something to do with the charge they carry. That is their potentials. Okay. This is also not the reason. So we are only left with the ionization potential is low. In alkali metal, we have NS1 configuration. When NS1 upon losing electron will become NS0. So it will tend to become this. Okay, it will easily lose electron. That is, will oxidize itself and will act as a reducing agent. In the next question, formation of oxide ion from an oxygen atom acquires first an exothermic, then an endothermic step. Yes, we all know that. Thus, the process of formation of O2 negative in the gas phase is unfavorable. Even though O2 negative is isoelectronic with neon, it is because, see, what happens is, in this case, when we form O negative, it will have del H equals to negative. Okay. Now it already has electrons. If we give it one more electron, then it will repel. Okay. One addition of electron, repulsion will increase. Okay. So that is why electron repulsion will outweigh the stability that will be gained by the noble gas configuration. Now let's see the next question. Which ionization potential is in the following equation involve the greatest amount of energy? Okay, so let's see. The highest positive charge here is on C2 plus. Okay, so to remove even more electrons, we have to give great amount of energy. Okay, because if any species, see for example, I have a raised to the power n positive. If n is more, that is effective nuclear charge, that is Z would be more. So in case of out of all these, this has the most Z effective. That is why it will have to require most amount of energy, most ionization, maximum ionization potential. Okay? Now let's see the next question. Select the correct order for the property given in the brackets. See, you have to select the correct order. Here, this is wrong. It is electronegative, so we'll have to like it will not easily accept. Wait, okay. Then for this, yeah, this is right. Why? Because fluorine already has so many electrons. Therefore, electron repulsion would be there upon addition of electron. Okay. And in case of chlorine, it has 3d empty orbitals, so it will gain electron easily, and also 3d7. Okay. Sorry, not 3d7. It has vacant, and after this we have in the outermost shell. It has 7 electrons. It will easily take 1 electron to achieve noble gas configuration. Okay, so this would be our correct answer. The next question is the general outer electronic configuration of D block elements is. We all know it would be this. Okay, not this because it is NS 0 to 2. It can have 2 electrons as well as 0 electrons. Let's see the next question. Select the correct order of the given property. Bond energy, no, this is wrong. This would be the case because size would increase on moving down the group, so more energy would be required to break the bond. In this case, this is also wrong. Why? Because see, you need to like CO is this C triple bond O. You need to provide maximum energy to break a triple bond. And in case of yes, this is the right answer because C N double bond O is stronger. Okay, this is very strong bond. In NO2 negative, what happens is because of extra addition of extra electron, the bond strength is weakened because of electron repulsion. In case of NO3 minus, it is further decreased because we already had so many electrons. And if on addition of oxygen, what will happen? It will be even further decreased. Okay. Also, this is resonance stabilized, so its energy is low. Anything that has more stability has lower energy. Let's see the next question. Fluorine is a stronger oxidizing agent than chlorine because, see, this is a very famous question which is asked in CBSE and any other exam. This is because low chlorine-fluorine bond dissociation energy is there and high hydration enthalpy of fluoride is there. So, correct answer would be this. Okay. Let's see the next question. Assertion is given that Na positive and Al3 positive are isoelectronic, but ionic radii Al plus 3 is smaller than Na positive. The reason given is, see, this statement is true. The reason given is the nuclear attraction on the outermost shells of Al3 positive is greater than the nuclear attraction on outermost shells of electrons of Al3 positive is greater than Na positive. This is also correct. I told you earlier that more is the N positive, more would be the Z effective. Okay. So this also explains why the size changes. So it is the correct explanation. Let's move to next question. It says the electron gain enthalpies in kilojoule um, of three halogens X, Y, and Z are respectively this much. Then for X, Y, Z. Okay, so We all know the electron gain enthalpy of fluorine is lesser than chlorine. Okay, so this would be the answer. See, generally, generally the electron affinity will decrease down the road. Okay, fluorine has electron affinity less as compared to chlorine. I told you earlier why, because of because the size of fluorine is less, so electronic repulsions would be there. So its energy would decrease. So this would be the correct answer. For maximum for we see here chlorine because it is decreasing down the group. So less for bromine. Let's see the next question. The incorrect order is see we know. Let's see the Kazan's rule. Okay, covalent. Whenever you see covalent character type question, always remember what will be applied Kazan's rule, according to which smaller the cation and larger the anion. Okay, smaller the cation and larger the anion, more will be the covalent character. See, um, here this is the smallest. These are group two elements, alkaline earth metal. So out of which smallest is this, therefore it will have most covalent character. So this is correct. Thermal stability. This is also correct. Why? See anions. Larger anion means larger covalent character and lesser ionic character. So that is why. Okay. Thermal stability will also decrease as the bond strength between the lead and the halide ion. Okay, the lead and the halide ion will change. Okay, see here the correct order is this. Why? Because PBI here the halide is the largest in size. Okay, so we will require lesser energy to make this bond, and it is because it is less thermally stable. This is also correct. Melting point order. See, melting point decreases as ionic size will increase. So this is also correct. Boiling point order. See, this will be our answer. Why? Because the boiling point will increase down the group because the van der Waals forces will increase. So this is the answer. The correct order would be this. Okay. Now let's move to the next question. Match column 1 and column 2 and select the correct answer by the given codes. Let's see. This we know this is the order of what? Ionic radii. Okay. Then let's see the easiest one first. Electronegativity. According to size, this will be the electronegativity order. DR. We need DR. Here it is GR. Let's see the fourth option. Here also it is GR. Okay. And we meshed what we meshed A with Q. A with Q is in this, and here it is AS. So our correct answer is this. Okay. You have to eliminate other options. You have to get to the correct answer in lesser time. Okay. So the best trick is by eliminating. Okay. See, the cation will, with greater positive charge, will have a smaller radius because of the greater attraction to electrons of nucleus. That is why this is the atomic ionic radius. And see, positive charge is inversely proportional to ionic radii, and negative charge is directly proportional. For and another concept here would be greater the positive charge increases the nuclear charge. I told you, like greater positive charge, it will become smaller and smaller. The ion will become smaller. Electrons will be losing and it will be smaller. So the nucleus can easily have its effect on it. So it will have a more effective nuclear charge. Okay, in case of isoelectronic species. While for the same group elements, effective nuclear charge decreases down the road because size increases. Okay, size will increase, shells will also increase. So that is why, because electrons are increasing, nuclear charge is decreasing. And electron affinity of fluorine is the highest in the halogen field. We all know that now because of the interelectronic repulsions of fluorine. Now let's move to the next question. The incorrect order of size. What is the incorrect order of size? See, in a period, the size decreases. So this is the incorrect order. It should have been carbon, nitrogen, oxygen, then fluorine. Okay, this is wrong there. Let's see the next question. Which of the following will have the most negative electron gain enthalpy? By now, we already know that fluorine is one shot of uh, extra stable configuration. It will easily have the electron. And why fluorine is less? Because we all know now, because of the interelectronic repulsions. Okay, it will. Chlorine has lesser electron repulsion. This also has small size. It will also have electron repulsions. Okay. So in the next question, the sum of ionization energies of aluminium are this, and the sum of first two ionization energy of Na is this. Aluminium is this, and Na is this. So out of Al3 and Na2 positive. Let's see. The configuration here. Just a second. Okay, am I clear right now? Yes. So the ionization energy is not the only criteria for the stability. Okay. Then Al plus 3 is more stable because it has inert gas configuration. You see, it has already lost 3 electrons, so it achieves the stable configuration. Whereas Na2 plus has non-inert gas configuration. This is its configuration. Therefore, aluminium is more stable than Na2 plus. So this is our answer. Let's see the next question. The assertion is given. Boron has a smaller first ionization enthalpy than beryllium. Yes, this is right. Boron in beryllium, it is 1:2:2, so it has a stable configuration. The reason is the penetration of a 2s electron to the nucleus is more. This is also correct. Okay, see, for beryllium, this is the configuration for boron, so it will easily lose and it will have a lesser ionization enthalpy. Now, boron has a smaller first ionization enthalpy than beryllium because 2p electron of boron is more shielded than nucleus by inner core electrons than 2s electrons of beryllium. Okay, so that is why both are the correct assertion and reason. And reason also explains the assertion. Now let's see the next question. Arrange S sulfur, phosphorus, arsenic in the in order of increasing ionization energy. See, this would be the answer. Why? Because as you move from left to right, the size will decrease. Okay, so what happens if the size decreases? Effective nuclear charge would increase and it would be harder to remove an electron. Therefore, an ionization energy will increase. Okay, let's see the next question. Hmm. Consider the following statements. The elements silicon, germanium, and arsenic are called metalloids. This is correct, absolutely correct. We have already seen it. And metalloids have properties quite different from those of metals. And non-metals. Yeah, it comprises both of these properties. So this would be the correct answer. Let's see the next question. Arrange an increasing order of atomic radii. Now we all know that we have to see which, in case of anions, this is like ionic radii will be directly proportional to negative charge. Okay, so our answer would be this. Let's see the next question. The second period elements consist of 8 elements. This is right. The number of uh, elements in each period is 4 times the number of atomic orbitals available in the energy. No, it is 2 times. Okay, so reason is incorrect. Assertion is right. Let's see the next question. The only non-metal which is liquid at ordinary temperature. C. Non-metal is asked. So what will be the answer? Okay, that is why bromine is a reddish brown liquid at room temperature and atmospheric pressure. Bromine is a non-metal. Match the column 1 with column 2. See, we have to match these. You have to learn this. Anilinium would be, see how it is made. Un plus nil plus un plus em. Okay, that is 101. Similarly for anilhexium 106, this is 103. Okay, 101 corresponds to mendelevium, 106 is for seaborgium, and 103 is for laurentium. The left one would be anilpentrium. You know, then it would be for cadmium. Now, in next question. The successive ionization potential of elements are this. The most stable oxidation state of the element. C. Now in this, among all these, there's a huge gap between this. Okay. So that is, it will go in like from, this is almost same, but from IP4 to IP5, there's a huge gap. Okay. So, which shows that the elements attains a stable gas configuration after losing 4 electrons. Okay, that is why it would not like to go in the fifth oxidation state. Our answer would be +4. Let's see the next question. This is the last question. So it says element with electronic configuration. This is a D block element. Yes, assertion is correct. Why? The reason states the last electron enters the d orbital. We all know that any block element we name it after where the last electron is entering. So yeah, this is the correct answer. So that's all for today. Thank you. Have a nice day.